Good morning, ma'am.
Good morning. How
Good
are
morning, ma'am.
you? Good morning, ma'am.
Fine,
Good
ma'am.
morning. How are you
Good
all?
morning, ma'am.
Good
Fine, ma'am.
morning. Any
Fine,
doubt?
ma'am.
Yes, Risa. Like there was a Google Sheet, and it was regarding the queries from the students. So I have written that my students are asking me about the physical classes, beginning of the physical class, and laptop. Okay, so I have written for you all. Let's see what they will decide.
Thank you, ma'am.
Any doubt from the last class? We are discussing Gibbs-Helmholtz equation, and we have discussed Bhank's isochore and some numericals based on that expression, like final expression ln kp2 by kp1 is equal to del h by r t2 minus t1 by t1 t2.
Yes, ma'am.
Okay, so today we'll discuss criteria of spontaneity, and then application of this Gibbs-Helmholtz equation. Now whiteboard is updated. So we know Gibbs-Helmholtz equation, del G is equal to del H minus T del S. It can be used to predict the spontaneity of a reaction, whether the reaction is spontaneous or not. That can be predicted by using this equation. We know that del G is less than 0, then what will be the reaction? Will it be spontaneous or non-spontaneous?
Spontaneous.
It will be spontaneous. And if it is greater than 0,
Non-spontaneous.
non-spontaneous. del S is less than 0. And here del H is greater than 0. Del S is greater than 0. Less than 0, del S is equal to less than 0. If del H is less than 0, 0, and del S is greater than 0. Okay? So because you know del G is equal to del H minus T del S. So del H and del S values will be like that, so that it should be less than 0. Then it will be spontaneous. If it is greater than 0, then it is non-spontaneous. Okay, so next we'll discuss application of Notch equation. You know that if G is less than, del G is less than 0, then the reaction is spontaneous. Let's solve this question for a reaction. The value of del H is equal to 30 kilojoule per mole. Del S is equal to 0.07 kilojoule per mole.
इक्वेशन क्या लिखी है?
Just a minute. The reaction would not be so for a reaction M2O gives 2M half O2. Del H is given. Del S is given. Okay, at 1 atmospheric pressure, then you have to calculate up to which temperature the reaction will not be spontaneous. Do you understand the question? So what you have to calculate, you have to find out the temperature. Okay, you have to find out the temperature, and you'll put that del G is less than 0 because it is not spontaneous, so it will be greater than 0. Okay,
O के साथ क्या है मैम?
क्या है? half O2 gas, half O2 gas.
M2 के बाद?
So it is a metal oxide. It is solid. Okay, so after in the product side it is 2M. It is also solid. Then half O2 it is gas. Is it okay now?
Yes ma'am.
Is it 428.57 Kelvin?
Yes. Yes. This should be the answer. Everybody got this answer?
Yes, ma'am.
Anyone who could not solve this one? Who could not solve this one?
What's the answer? Okay, I'm done.
Done, ma'am.
So everybody could solve this one?
Yes, ma'am.
So next application is okay to find thermodynamic parameters during electrochemical cell operation. Okay, so again by putting in Gibbs-Helmholtz equation minus NFE is equal to del H minus NFT del E by del T at constant pressure. because Gibbs Helmholtz equation is equal to del G is equal to del H plus T del G by del T at constant pressure. So if you will put the value of del G in this equation, then you will get minus NFE is equal to del H minus NFT del E by del T at constant pressure. Okay, so it can also be written as del H is equal to del G plus T del S. So del S is equal to NF So this equation del S, this is the expression for del S, and this is for del H. And again you know that del G is equal to minus NFE. These three equations, these three relations, these three can be applied. Can be applied to find out the enthalpy, E energy, and entropy change during cell, electrochemical cell operation. Okay? Or any doubt up to now? So now you solve this
थोड़ा
question.
ऊपर करिएगा थोड़ा सा
ऊपर करो
थोड़ा सा
हुआ मैं अपना वीडियो ऑफ कर दिया कि आपका बेटर विजिबिलिटी के लिए
ओके मैम हो गया
अभी ठीक
सर हो गया मैम
हो गया ठीक है Now we'll solve a question based on this expression. So find the thermodynamic parameters Yeah.
Sir, screen is not visible. It's black.
Yes, yes. अभी विजिबल है क्या?
Yes, ma'am. It's okay.
हाँ, ये चला गया था. And the thermodynamic parameters accompanying the operation of a standard cadmium cell, the cell potential and temperature coefficient. Here temperature coefficient is del E by del T at constant pressure. So this is called your temperature coefficient. Coefficient of the cell are 1.018 at 25 degrees Celsius, and this one temperature coefficient is -5 into 10 to the power -5 volt per Kelvin. So this del E by del T at constant pressure is given, E is given, cell potential. Then you have to find out del G, del H and del S. In the meantime, I am taking your attendance. Roll number 66. Respond to your roll calls. Roll number 66.
Yes, ma'am.
67.
Present, ma'am.
68.
Present, ma'am.
69.
Present, ma'am.
70.
Present, ma'am.
71.
Present, ma'am.
72.
Present, ma'am.
73.
Present, ma'am.
74.
Present, ma'am.
75. 75. He was here.
Present, ma'am. 75.
76.
Present, ma'am.
77.
Present, ma'am.
78.
Yes, ma'am.
79.
Present, ma'am.
80.
Present, ma'am.
81.
Present, ma'am.
82.
Present, ma'am.
83.
Yes, ma'am.
84.
Present, ma'am.
85.
Present, ma'am.
86.
Present, ma'am.
87.
Present, ma'am.
88.
Present, ma'am.
89. 89. 89.
Ma'am.
90.
Present, ma'am.
91.
Present, ma'am.
92.
Present, ma'am.
93. 93. 94.
Present, ma'am.
95. 95. 96. 96, 97,
Present, ma'am.
98, 98, 99,
Present, ma'am.
800,
Present, ma'am.
801, 801, 801, 2,
Present, ma'am.
3,
Present, ma'am.
4,
Present, ma'am.
5, 805, 6, 806, 7, 8,
Present, ma'am.
9,
Excuse me, ma'am.
yes,
807 present.
okay, 809, 10,
Present, ma'am.
11,
Present, ma'am.
12,
Present, ma'am.
13,
Present, ma'am.
14,
Present, ma'am.
15,
Present, ma'am.
16, 816, 17,
Present, ma'am.
18,
Present, ma'am.
19, Ritika Singh, 20, 21, roll number 821, 22,
Present, ma'am.
23,
Present, ma'am.
24, 25, roll number 825, 26,
Present, ma'am.
27,
Present, ma'am.
28,
Present, ma'am.
29,
Present, ma'am.
30,
Present, ma'am.
31,
Present, ma'am.
32, 33,
Present, ma'am.
34, 34, 35, 36,
Present, ma'am.
38,
Present, ma'am.
39,
Present, ma'am.
40,
Present, ma'am.
41,
Present, ma'am.
42, 43,
Present, ma'am.
Ma'am, you got 42.
44,
Ma'am, I'm 42. I'm present.
44, 45,
Present, ma'am.
46,
Present, ma'am.
47,
Present, ma'am.
48,
Present, ma'am.
49,
Present, ma'am.
50.
Present, ma'am.
Ma'am, I'm 42.
हाँ दे दिया.
Ma'am, I'm 44.
Okay, just let me check who are absent today. 793, Debjyoti Gun, are you present? No. 795, 796, 798, 801, 805, 806.
Present, ma'am.
Okay. 809, 816, 819,
Present, ma'am.
820, 21, 824, 834, 835, okay, 844,
Present, ma'am.
okay then. I have updated the attendance now, it cannot be changed. So I hope in the meantime you have solved this question. What is the value of del G? What is the value of del G?
minus 196474 Coulomb volt.
Minus 196.47 kilojoule.
Yes, ma'am. I have written Coulomb volt. Yeah, that's only.
So I think everybody could solve this one, or shall I solve?
Solve.
I'll solve or you will solve? Are you asking me to solve it?
Yes, ma'am.
Yes, ma'am.
Okay. You know del G is equal to minus NFE. So what is the value of E here? E is equal to 1.018 and F is equal to
96500.
okay. Then what is the N in cadmium? N is equal to number of electrons taking part in this reaction is 2. So you put all the values 2 minus 2 into 96500 into 1.018. It will be minus 196.47 kilojoule. Okay? Or any doubt?
Okay, ma'am.
So then del H is equal to NF T into del E by del T at constant pressure. Okay. So now you put all the values 2 into 96500. And what is the value of T here? 25 degrees Celsius. So 298 Kelvin. So 298 into what is the value of del E by del T at constant pressure? What is the temperature coefficient here? It is minus 5 into 10 to the power minus 5. 5 into 10 to the power minus 5 minus E is equal to suitable 1.018. Okay, this much joule. So you now calculate, just solve this. Okay.
Yes, ma'am.
Similarly, del S is equal to NF del E by del T at constant pressure. Okay, so the value of N is known, F is known, del E by del T at constant pressure, that is also known. I think del S can be calculated, isn't it?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
everybody can solve this type of questions if you will get in your exam. Okay. So next application number 3. So it is to find enthalpy change at constant pressure. So Gibbs-Helmholtz equation can also be used to find del X accompanying a reaction, providing the values of free energy change at two different temperatures. Okay, so if you will get del G value at two different temperatures, then you can find out the change in enthalpy. Okay, so let us check how it can be used to find out the change in enthalpy when the del G value is given for two different temperatures. Okay, so if the del G values are given for two different temperatures, then we can find out the value of del H. So the free energy change for a given reaction is minus 90 kilojoule at 25 degrees Celsius and minus 85 kilojoule at 35 degrees Celsius. Calculate the change in enthalpy Okay, so free energy change for a reaction at two different temperatures are given. So you have to find out the enthalpy change for this reaction. So this is the last application of Gibbs-Helmholtz equation. I hope you can solve this one. Please try to solve, otherwise I will solve for you. So you try to solve first. So first of all, you have to find out del G, change in free energy with respect to temperature at constant pressure. So that is equal to two different temperature. In two different temperature, del G value is given. So it is minus 85 minus 90 kilojoule at 25 degrees Celsius. So let it be T1, and similarly it is minus 85 kilojoule.
Ma'am, is it minus 239?
Answer?
Yes, ma'am.
Yes. Sorry. Yes, answer is minus 239 kilojoule.
Okay, ma'am.
Everybody got this answer? Everybody got this answer or not? Okay. So in two different temperatures, it is given. So 25 degrees Celsius to Kelvin, you can like change it to Kelvin. So what will be the answer? It is 298 Kelvin, and it is 308 Kelvin. Okay. So you can put minus 85. So this is equal to minus 85 minus of minus 90 divided by delta T is 308, change in temperature 298. How much this one? 0.05 kilojoule per Kelvin.
Ma'am, 0.5.
Sorry, it is yes 0.5 kilojoule per Kelvin. So they have asked for 30 degrees Celsius. Del G at 30 degrees Celsius. So it is minus 95 plus minus 85 divided by 2. Because in the like mean 25 and 35 in the mean range, we have to find 30. So it is minus 87.5 kilojoule. So now from Gibbs-Helmholtz equation, del G is equal to del H plus T into del G by del T at constant pressure. So that is equal to del G. So this one del H. Del H is equal to del G.
Excuse me, ma'am.
Yes.
Ma'am, can you explain that delta G at 30 degrees Celsius?
Because you have the temperature 25 degrees Celsius. Okay,
Yes, ma'am.
del G value is given. So you have to find out 30 degrees Celsius, and already given 35 degrees Celsius.
Yes, ma'am. Understood. Yes.
Okay. So now del T is equal to del H minus T del S. Okay. Sorry, del G is equal to del H minus T del S. So if we put all the values, then it will be del H plus T. The value of del S is equal to del by del T. Now del H is equal to del G minus T into del G by del T at constant pressure. should be the answer.
Excuse me, ma'am.
Yes.
Could you please scroll the screen a bit up?
Is it okay?
Ma'am, could you please show the question once more? Yes, ma'am. Thank you, ma'am.
Is it okay? Completed?
Yes, ma'am.
Okay then. We'll teach. I'll teach in the next class. Clapeyron classification equation. Okay, gives a Helmholtz equation is completed and the problems related to this application of Gibbs Helmholtz equation, problem related to Gibbs Helmholtz equation. So these are completed. Okay. So next class we'll discuss Clapeyron classification equation. Okay then.
Okay then.
Okay, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank
Ma'am,
you.
this Saturday class or not?
क्या है? इसी
Ma'am, this
सैटरडे
Saturday.
नहीं है, नहीं है. मुझे तो
Okay.
नहीं लग रहा कि ये है. नहीं है तो.
मैम वो दूसरे सेक्शन वाले बोल रहे थे कि उनको
क्या है?
बोला गया. मैम वो दूसरे सेक्शन वाले बोले थे कि उनको बोला गया है कि पिछले सैटरडे छुट्टी था तो इस सैटरडे क्लास हो.
मुझे नहीं पता. हम लोग को कोई
नोटिस नहीं आया तो कहाँ से क्लास होगा अभी तक?
नहीं
हाँ,
आया
वो तो
तो
दूसरे
कल
सेक्शन
तक
को बोला.
कल
उनका
तक
क्लास
देखते
होगा,
हैं.
हमारा नहीं.
कल तक देखते हैं. अगर आएगा तो बोल दूंगी, नहीं तो नहीं.
यस मैम. थैंक यू मैम.
ओके मैम.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Thank you, ma'am.
Okay, thank you.